All right, we're continuing here in AP Stat in Chapter 3 notes, but kind of encompassing a lot of what's happening in Unit 1. And we were talking where we left about frequency distribution, upper class limits and lower class limits. And we stopped right here with steps to make a frequency distribution. And it said to determine the number of classes or groups you need first, right? So figure how many groups or classes. In the prior example, I had hair color and I chose 3 classes or groups. If I was doing age, for example, I would choose 8 classes personally. Okay? And the reason why is I would not want my class size to be 1, or I would not see any kind of trends, right? If I used ages of everyone, 0 through 100, we'll just say, that would be 100 different classes, or even more, 0 through 99, technically, would be 100 different classes. So what kind of trends would I end up seeing? It might be harder to see them, but if I saw groups or chunks of people, it might make it easier. So for example, if I did like ages 18 to 44, I wouldn't want my class size to be each individual person between 18 and 44, because I would have too many classes, and again, would I even be able to see a trend? So that's what I mean, 18, 19, 20, like if I made all of them individual. So let's find the class width. All right, and you can make this whatever you want. It's your choice. I'm choosing I want 8 classes. All right, so here's how you would find. All right, you take the max value minus the min value, and then divide it by the number of classes. That's what this formula is for. So for example, if I'm looking for people in between the ages of, back here it said 18 to 44, right? If I want 18 to 44, I do the 44 minus 18, and because I'm deciding I want 8 classes, all right, I'm basically saying, all right, that's roughly 3.25 per class. Class width must be whole numbers, okay? Can't have 0.25 of one. Thus, we normally always round up to figure out what our class size should be. Always round up. It doesn't matter if this is 2.5 and I should be closer to 3, round up, it's 4. So if I want 8 classes of all of those in between there, I'm basically saying I want to do every 4 ages. Right? So even if it's 3.0000, you still round up to 4. If we do not round up, then somewhere along the line I'm going to end up cutting out something from my sample. So, thus, for this example, my class width is 4. So that's why between 18 and 44, even though this is more than the 44 that I want, it is, but I did 4. 18, 19, 20, 21, that's 4. All of these, that was my classes. I have my 8 classes to decide the group size. So now frequencies. All right. So notice there is width of 4 between each of them. Right. They're all width. To make this table accurately, you start with the minimum and go up 4 from there each time. So notice up 4, up 4, up 4. Even this is up 4, up 4, up 4 each time. To find the class midpoint, right? You take the upper class and the lower class and then add them up and divide by 2. So class boundaries, all right, what those are, used to separate our classes without gaps. Okay, so for our data, the lower class limit is 18, 22, 26, right? These 18, 22, 26, these are the lower class limit. This class is the upper, that is the lower, that is the upper class. This is why I said that when we went over this in the last video, some of you might have been confused on what lower and upper class means. It's easier with a visual aid here, right? Lower, upper, lower, upper, lower, upper. What this is saying is to find the class midpoint, you add them up and then divide by 2, and you could literally find the midpoint of them, all right? Lower class limits were this, the upper class limits, right, were this for all of them. Showed you that before. So the class midpoint of each, I just add them up, divide by 2. Divide by 2, that's what I'm showing you, each class. Me adding them up and dividing by 2. That's all that I just did there. All right, and again, I'm moving fast, but you can pause the video and you can write the stuff down. Please don't forget to do that. This is me just showing you all I did was add them up and divide by 2 to find the midpoint of each class. And the class boundaries are used to help make the histograms. All right, so when we get to that and we start making histograms, the class boundaries are going to be used to help make histograms. All right, they are upper bounds of one class and the lower bounds of the next class, averaged together. That's key here. That will give me a boundary. It is the upper bound of the one class and the lower bound of the next. All right, that will give you your boundary. So for our data set, all right, it was 21 to 22. And where is it? It's here to show you quick. Right here. 21, upper of one, and then here is the lower of the next. That's 21.5 would be my class boundary that we're talking about. And 25.5 is a class boundary. 29.5, this helps histograms because you can't have a space in between them when you're talking about histograms. So these are all of the class boundaries. All right, histograms bump right up against each other. There's no spaces in between. So technically I need to know where it started to keep the same distance with my boundaries in making a histogram. I need what the first boundary would be in order to have the same spacing. So my point is, if I look at all these, it seems like it's 21.5, 25.5. So my point is, I started at 18, right? 18 to here is 3.5, but then from here to here is 4, here to here is 4, here to here is 4. It's 4 everywhere else, but it started at 18. So my point is, maybe I need my graph to start at 17.5, right? Just to fit and have the same spacing each time, right? I need what the first boundary would be in order to make the same spacing. It doesn't start at 18 and then go like this each time to find my histogram spacing, right? It's not the same spacing the entire way. But if I do the same spacing right from the start, it would work great. So why don't I start at 17.5? And then it would be the same spacing. All right, it will be evenly spaced then the entire way. So let's fill the same values. So let's say our table is this. I'm making these up. So before everyone jumps the gun and says, wait, where'd you get these from? I'm just giving them to you, okay? I'm just saying I calculated it in the group. Oh, look, here's how many people are in between the ages of 18 and 21. That's all this is, okay? Just me making up the numbers of what I saw. We can use our data to create a relative frequency distribution. Right, a relative frequency distribution. And a relative frequency distribution will give you the percentages. Okay, so the percentages. So using the data, what's my total? Right, I just take all of them and add them up to get 43. That's all I did. 43. Just add them all up. 43. Right, so n equals 43. That is my total number of whatever we're looking at. All right, n. Or what we're saying here is this is a sign you're going to get used to. That is a summation sign. A summation of f is 43, as in a summation of all of the numbers in f is 43. Depending on the book, depending on what you see. I don't want you to look at it and get freaked out, which is why I'm going over it. So now let's find the percent. If it's out of 43, basically I just divide each one by 43 to figure out the percent, and then multiply it by 100, and it will tell you that percent. Point being is 25 divided by 43, 10 divided by 43, 4 divided by 40, 2 divided by 1 divided by 43, 0 divided by, and I do that for each one, and then I multiply it by 100. These are the percents for each one. Okay? Fun fact, if people say most, all right, so here's your first little statistical tidbit of knowledge to drop. If people say most, as in most people on the frequency table are between 18 and 21, the word most means above 50%. Anytime you use that, all right, when you say most people, that means it's more than 50%. Okay? So keep that in mind. Most people are not. Most people are in between 18 and 21. Most people. Fun fact 2, the percent may not add up to exactly 100% when doing these tables, but it should be ridiculously close. Okay? Should be close. Please keep that in mind. Next up is the cumulative frequency distribution tables that we'll be talking about. And this example would be to continue to add the sequential classes together each time. All right? So cumulative meaning adding things up as we go, right? So, for example, this is 25, but the cumulative frequency I take 10 more to it, that's why it's 35. I take 4 more to it, that's why it's 39. 2 more to it, 1 more to it, none to it, 1 to it, none to it. Getting up to 43, you keep adding what that is each time, right? So the data, the normal data. Normal means the data goes up to a certain point and comes back down. That's what it means, that the data goes up to a certain point and comes back down. Normal. Okay? Eventually we're going to talk about normal curves. Normal curves kind of go up and they come back down. That's what they do. The data we are currently looking at is not normal. Okay? Does it look like the data goes up and then comes back down? No. Why? Because most of the data in the beginning, it's most of it in the beginning, and then it seems to kind of tail off, right? Think about it. 25 right away, then 10 kind of goes down, then it's 4, 2, barely anything. It's tailing off. Starts off big, right? Works its way down towards the end, so it's not normal. Tails off. Starts high, works its way down to low. Normal distribution looks like this. Huge, huge, huge idea for all of statistics right now is this. Your normal curve, boys and girls. All right. Eventually what you're going to realize is all graphs aren't normal, but if we can try to force them into being normal, then we can end up finding information about the data if it's not already normal. Okay. It rises and has a peak in the middle, right? Rises and has a peak in the middle. A histogram, all right? Something else we're going to look at. It's just a bar chart that touches and has no gaps. We kind of went over that before, all right? And you can get a histogram that kind of fit the same thing as well to see if it looks like it's normal by the judge of the histogram, okay? The histogram, no gaps. It looks like a bar graph, but there's no spacing in between them. So I'm going to show you how to use your TI-84 calculator to make histograms of data, all right? So again, something else that is very important to go over. All right. You press the second and stat plot and use the arrow keys to turn the stats on. So second stat plot. All right. And then you have to turn your stat plot on and press enter. Then you can use the arrow keys and select histogram from them, press enter. This wasn't a very great way of showing it. This is all the writing for it later down the road. I kind of learned from this, and I have the exact buttons to press on the calculator as we go through. But for right now, for this one, to see where the histogram is, second stat plot, you turn the stat plot on because we're going to be using our stats in order to graph. Press enter. There is a graph icon that looks like a histogram. You want to press enter on that and be sure there are no graphs in your y equals function, because if there are, it's going to show up with a function amidst your graph. All right, and you should have a histogram. So I'm going to show you where all this stuff is when we get back, so you can make sure your plot is on and all of that.